Tesla's new motor delivers 800 kilometers range using 50% less power, making every current EV look ancient. This isn't just efficiency. It's the breakthrough that eliminates range anxiety forever. But here's what's really happening. Tesla cracked the code without expensive rare earth materials that competitors depend on. This motor could trigger the biggest industry shakeup since the iPhone launched. What does this mean for every other automaker? Let's dive right in. Tesla just achieved what every automaker said was impossible: an electric motor that delivers 800 kilometers of range while using 50% less power than any existing EV technology. To understand why this makes every current electric vehicle look ancient, consider this comparison. A standard Tesla Model 3 today consumes roughly 15 kilowatt-hours per 100 kilometers. This new motor drops that to just 7.5 kilowatt-hours, while extending total range from 600 kilometers to 800 kilometers. The engineering breakthrough centers on Tesla's rare earth-free design that completely eliminates the supply chain vulnerabilities plaguing every competitor. While BMW, Mercedes, and even BYD depend on expensive neodymium magnets from China, Tesla cracked the code using advanced flux technology and minimal permanent magnet materials. Here's what few people realize. Traditional EV motors are essentially 20th century technology adapted for electric vehicles. They suffer from heat buildup, efficiency loss at high speeds, and power degradation over time. Tesla's motor operates like a completely different machine. Think of it as the difference between a steam engine and a jet turbine. Both move vehicles, but one represents a quantum leap in engineering sophistication. The technical specifications reveal the magnitude of this achievement. Current industry-leading motors from companies like Lucid and Mercedes EQS achieve peak efficiency around 95%. Tesla's new motor maintains 98% efficiency across the entire speed range while generating 40% more torque per kilowatt consumed. And here's a detail most overlook. The motor runs 30 degrees Celsius cooler, eliminating the thermal management issues that limit sustained performance in luxury EVs. But the real breakthrough isn't just efficiency, it's reliability. Traditional motors require complex cooling systems, frequent maintenance intervals, and performance derating in extreme conditions. Tesla's design operates continuously at peak performance without thermal limitations. Early testing in Cybertruck prototypes shows the motor delivering maximum torque for hours without temperature-related power reduction. Tesla's vertical integration strategy now pays unprecedented dividends. While competitors wait 18 to 24 months for motor suppliers to develop competing technology, Tesla iterates monthly within their Gigafactory network. They control every aspect: magnetic materials, winding techniques, cooling integration, and software optimization. But this is just the beginning. What's really surprising is how this single motor makes Tesla's entire product lineup suddenly superior to anything competitors can offer. This motor breakthrough arrives precisely when the global EV market reaches its most competitive phase, and the timing couldn't be more devastating for Tesla's rivals. Here's why. Every major automaker just committed billions to EV platforms that are now fundamentally obsolete before reaching full production. Consider the competitive carnage this creates. Ford's F-150. Lightning, currently praised for its 500-kilometer range, suddenly looks primitive next to a potential Tesla truck delivering 800 kilometers with faster charging and lower operating costs. Lucid Air, marketed as the longest-range EV at 800 kilometers, achieves that range with a massive 118 kilowatt-hour battery pack. Tesla's new motor could deliver identical range with a 60 kilowatt-hour pack. The economics become devastating for competitors. BMW's iX requires an $85,000 price point to achieve 600-kilometer range profitably. Tesla could theoretically offer 800 kilometers range at $45,000 while maintaining higher profit margins. That's not competition. That's market elimination. But there's a strategic dimension that changes everything. Tesla isn't just building better motors. They're creating an insurmountable moat. While competitors scramble to reverse engineer this technology, Tesla continues advancing to next-generation designs. By the time BMW or Toyota develop competing motors, Tesla will be 3 iterations ahead. The supply chain implications are equally dramatic. Tesla's rare earth-free design eliminates dependencies that constrain every competitor. While other manufacturers face material shortages and price volatility from Chinese suppliers, Tesla scales production without geographic constraints. This advantage becomes more pronounced as EV demand accelerates globally. Here's what's truly noteworthy. Major automakers now face an impossible choice. They can abandon current EV platforms mid-development, losing billions in sunk costs, or continue producing inferior vehicles destined for market irrelevance. Either path leads to massive losses and market share erosion. The timeline pressure is relentless. Tesla plans to integrate this motor across their entire lineup within 18 months, starting with Cybertruck and expanding to Model 3, Model Y, and the upcoming Model 2. Competitors need 3 to 5 years minimum to develop and scale competing technology. Assuming they can solve the rare earth dependency issue Tesla already conquered. And here's why this changes everything. Tesla isn't competing in the EV market anymore. They're defining what post-EV transportation looks like. Tesla's 800-kilometer motor represents more than automotive advancement. It's the catalyst for transportation's complete transformation across every sector that moves people and goods. The aviation industry faces immediate disruption potential. Electric aircraft development has been constrained by the fundamental equation of battery weight versus motor efficiency. Current electric planes achieve 200 to 300 kilometers range, carrying 2 to 4 passengers. But here's what most people don't realize. Tesla's 50% efficiency improvement doesn't just extend range, it transforms payload calculations entirely. If Tesla's motor technology scales to aviation applications, electric regional flights become economically viable. A 400-passenger electric aircraft suddenly moves from impossible to inevitable. Elon Musk's repeated references to electric aviation aren't speculation. They're preparation for market entry when the technology matures. Maritime shipping represents an even larger opportunity. Global cargo ships consume 300 million tons of heavy fuel oil annually, generating 3% of global CO2 emissions. Tesla's motor efficiency could make electric shipping feasible for routes under 2,000 kilometers, covering 60% of global shipping traffic by distance. The space connection is more immediate than people recognize. While rockets won't use these motors directly, the engineering principles enabling maximum efficiency in Earth's atmosphere could revolutionize SpaceX's satellite positioning systems and future Mars rover designs. Every efficiency gain matters exponentially in space applications. But there's a challenge few acknowledge: production capacity constraints. Tesla's Gigafactory network, already operating near capacity for automotive demand, would need massive expansion to supply motors for aviation, shipping, and space applications. This represents the most significant industrial scaling challenge since World War II manufacturing mobilization. Competition will inevitably attempt response. Within 24 months, expect emergency R&D programs from General Motors, Volkswagen Group, and Chinese manufacturers. However, Tesla's technical lead and vertical integration create barriers that may prove insurmountable for traditional automakers structured around supplier relationships. The realistic timeline for broader adoption: automotive impact within 12 months, commercial trucking transformation within 24 months, aviation prototypes within 36 months, and maritime applications within 60 months. By 2030, Tesla's motor technology could power the majority of new vehicles, ships, and aircraft globally. Perhaps most significantly, this breakthrough eliminates the final argument against electric transportation: performance limitations. When EVs offer superior range, power, reliability, and cost compared to combustion alternatives, the transition becomes inevitable rather than aspirational. The convergence of Tesla's motor breakthrough, rapidly improving battery technology, and expanding charging infrastructure creates conditions for transportation's fastest transformation in human history. We're not witnessing incremental improvement. We're seeing the moment internal combustion engines became obsolete technology. This is exactly why Tesla's 800-kilometer motor represents more than just better EVs. It's the moment transportation itself became a solved problem. When one company can deliver twice the range with half the power consumption, we're not looking at incremental improvement. We're witnessing the technological inflection point that makes internal combustion engines as obsolete as steam locomotives. What this means for the broader picture is profound. SpaceX's mission to make life multiplanetary requires revolutionary efficiency in every system, from Earth-based manufacturing to Mars surface operations. The engineering principles behind this motor, maximum output with minimal input, directly translate to the resource constraints of space exploration, where every joule of energy matters. And this is just the beginning. Within 18 months, Tesla will scale this technology across their entire lineup. By 2026, expect aviation prototypes. By 2030, we could see the first electric cargo ships crossing oceans. The same efficiency breakthroughs enabling 800-kilometer car range today lay the groundwork for electric aircraft that could eventually support Mars colony logistics. But here's what I find most intriguing. How do you think traditional automakers will respond when their entire product portfolio becomes technologically inferior overnight? Will they adapt fast enough? Or are we about to witness the automotive equivalent of what happened to Nokia when smartphones arrived? This is Tech Revolution, and we dive deep into the breakthroughs reshaping our technological future. If you want more analysis like this, hit subscribe. We're tracking every development that brings us closer to becoming a truly multiplanetary civilization. The age of limitations just ended. The age of possibilities is just beginning.